In this video, we're going to cover simplifying rational expressions. This is from Monday and Tuesday on January 20th and 29th. Worksheet 12.1. The algebra students will be working on this assignment for problems 1 through 18. So as I go through these, I'm going to be doing some of the problems all the way through. Some of them I'll only do a part of the way through and leave it up to you to get the rest done. You can always ask questions in class for extra help. The first problem, and our goal here is to simplify the rational expressions. State when excluded values, other variables exist. I'm going to be lenient on this one. I may wait till the end of this lesson to show you what a restriction on variable is. So I'll explain that later. But for right now, let's look at just working out the problems themselves. What your goal is to simplify this down. And you have a numerator and denominator, and they'll be working against each other, and you want to simplify it to its simplest form. Now, you won't have to do this on your paper. I'm just going to do this for illustration. On the top is 12 times a. On the bottom is 48, a to the third power, which means a times a times a. Now, anything that's the same on top and bottom will cancel. So I have a matching pair of a's. A divided by a just by itself would be 1. So those will cancel out. 12 is a fourth of 48. So I'm going to simplify it like that. And a reduced version of this answer will be 1 over 4, then a to the second power. Since I have two a's, just simplify that with an exponent. So a slightly longer version of this problem is number 3. Simplify your coefficients first. So you have 6 over 3. That's the same as 6 divided by 3, which would be 2. And the 2 would be in the numerator. You have 2 a's on the bottom. That's a to the second power. And you have 1 on top. So just like the other example we just got through with, 1a will cancel with 1a on the bottom. You have 1b on top and 2 on the bottom, meaning 1b will cancel with one of the others. I'm just going to mark the exponent out. And there's nothing that will simplify on the c to the third power. So in the numerator, I have 2c to the third. In the denominator, you have 1a and you have 1b. That's as far as it'll go, so you're done. All right, number 4. This is slightly different. You have n plus 6 on top, and I'll put that in parentheses. And you have an n plus 6 on the bottom. You also have this 3 out here. So the way you handle that, actually, the two binomials, since they're the same, will just cancel out. N plus 6 divided by n plus 6 would just be 1. There is a numerator, though, and that numerator will be a 1. So all you have left is 1 over 3. So simplify your binomials, your two n plus 6's, just like they were the same, like a and a. All right, number 7 is the same way. You have two binomials on top and you have 2 on the bottom. But the ones that are the same will cancel out. So I have c plus 5 on top, and on the bottom I have c plus 2. Now at this point, I do always have some students that want to cancel the c's because it's the same on top and bottom. I want to caution you that you can't do that. These are locked in parentheses. And I'll explain that a little more in class later. But just so you know about this, the c of c plus 5 is divided by c plus 2. So is the 5. So these are equivalent mathematical expressions. You do not need to do this. Right? That's not a necessary step. This is where you will stop. All right, number 9. You see I've got a little tag over here that says factor first. That's going to be a rule anytime you're working with factoring, anytime you're working with simplifying. And I have a squared minus b squared on top. Well, that is a difference of 2 squares. And you've already had some experience in factoring those. So a squared minus b squared can be factored into a plus b times a minus b. So factor those out first. The a minus b comes in underneath. Those will cancel just like the last example. So your answer is just a plus b. there's a 1 in the denominator position, you don't need to put that there. Now to show that in a slightly different way, one way that I like to work, and that you'll see me do a lot of my work is working up and down. Instead of working horizontally across like I did here, I'll factor to a plus b, a minus b above this numerator, and then cancel. So my next step would go straight here, skipping all of this step. Right? There's no point in writing something unnecessarily. You can easily forget something. So you'll see me write up and down. All right, number 12, again, you're going to be factoring first. So what can you do with t squared plus 5t plus 6? You're going to split that into 2 binomials first, and I'll work vertically this time. And I'm also going to do the same thing to t squared plus 6t plus 8. So t squared will be t times t. And I need two numbers that add to 5 and multiply to be 6. That's going to be 3 and 2. And since everything's positive, it becomes t plus 3 times t plus 2. Now t times t, and I need two numbers that multiply to make 8 but add to make 6. That will be 4 and 2. And everything is positive, so we'll drop those in. Now for the simplifying part, the t plus 2's are the same, so those can go away. So my answer is t plus 3 on top with a t plus 4 underneath of it, and I stop there. Remember, you cannot cancel the t's. All right, 13, again, factor first. Let's look at this bottom trinomial first. It's a trinomial because there are 3 terms. So the s squared is s times s. Now two numbers that add to 7 and multiply to 12 will be 4 and 3. And everything is positive, so drop my plus signs in. Now the factor first part is going to apply not only to this trinomial, but to this binomial also. You notice I have a 3 here, and I have a 27 here. I have a common factor. So get your greatest common factor out first. 3 times s squared would give me 3s squared. If I pull a 3 out of 27, it leaves me with 9. But I have another difference of 2 squares here. So you notice nothing cancels yet. There's another step. I'm going to continue working vertically. And this is a work habit I'd like to see you get into. As you move out, you're getting more simplified as you go. As you work down, you're more simplified as you go, and you'll be working with your extreme top and bottom. So s squared minus 9 is s times s, 3 times 3. And since there's no middle term, one's a positive and one's a negative. So this is fully factored 3s squared minus 27 here in this top row. And this trinomial is fully factored at these 2 binomials. Now to simplify, I have an s plus 3 in common. And looks like that's it. So for my answer step, my numerator is 3 times s minus 3. And for the denominator, it's s plus 4. I'm going to stop right there. This upper part is fully factored. If I were to distribute that back out to 3s minus 9, I wouldn't accomplish anything. Also, I would have a common factor that would need to be pulled back out to this step. So just stop here. Remembering where to stop or understanding where to stop sometimes is a difficult portion of algebra. All right, the next one I want to do is 14. And I think on this one, I'm not going to give you the full answer to this one. I want to show you where to start. But I'm still going to factor first. On top, I have 7k to the 4th. But you notice the other 2 terms, I have k also. So I'm going to factor out the smallest one here. Let's see. I'm going to factor this k to the 2nd power out on the bottom only. So my first term, if I take 5k to the 3rd and factor out k to the 2nd, I get 5k. Do the same thing to 2k squared, I'll get 2. So the next step in your problem is 7k to the 4th divided by k to the squared times 5k minus 2. Now just to give you a hint, you need to be looking at this and this. You can further reduce that, further simplify it. but you're not going to be able to do anything with this 5k minus 2 or the 7. So there's a hint to help you with 14. All right, and the last problem I'm going to do an example for. I'm not going to take this one all the way to the end either, but I'll give you a heads up on one of the complicated parts. It's just one more step. It's not harder, just more complex. Factor out this top part. Now that's going to be P. That's going to be P. That's going to be 2. That's going to be 1. But I'm going to leave the signs to you. All right, so you're going to need to fill in those two parts. We'll put some highlighter on that. So you'll need this and this. I don't want to give you too much on it. Now for the bottom part, just pay real close attention. This is P to the 4th power. The middle term is to the 2nd power. And the last term is a constant like you're used to. I can factor that. But P to the 4th will be P to the 2nd times P to the 2nd. Now I need numbers here that multiply to be 4 and add to make 5. So it's going to be 4 and 1. And the only way to make that a negative 5 in the middle is if your inner and outer terms are both negative. This would be 1p to the 2nd. This would be 4p to the 2nd. So they both must be negative for that to work. Now let me get rid of this bottom part here, just illustrating the middle term, if I can get it all. And go back to the kind of tricky part. Both of these are differences of two squares. You can keep going and have 4 sets of parentheses. Mine are very even, but you can go on to have 4 sets of parentheses. These two would be p squared minus 4, and these two would be p squared minus 1, similar to what you have up here. So I'm going to stop on number 18. I want that to be somewhat of a challenge for you, just to extend out your knowledge a little further. And feel free to pause, do your work, check and see what kind of solutions you're getting on the ones that I already did. And if you get stuck on any of the 18, we covered about 8, 9. If you have any questions on the rest, feel free to ask in class, and we'll get that taken care of. Good luck.